So tonight we will discuss about an important but difficult task. Okay, difficult topic. This is not a fun. This topic is not a fun. Okay, it's really difficult, and you need to give attention. Okay, let us see how can I do this. So welcome everybody. Please remember that our test 2 will be next Tuesday, not Thursday. Okay. Okay. And another thing that I send you a what is that called? Study guide notification. Go to D2L and you will see the notification, and then study. Follow the guideline. And we will have in the next half I can discuss about, if you have any questions, then we can discuss. Okay, so let us start with the new topic, linked list. Okay, so I think some of you have already idea about linked list, but I don't expect that you will know it. But if someone know it, then that will be fine. So the topic linked list is related to a list, right? So let us start with the list. Remember that it's a linked list. This is plural, okay? But we start with a singular list. So what is a list? Like list, I have a number, like for instance 1. I have a list of something, anything. I can have a list or set. It's kind of set. Okay? List of numbers 1, 2, 3, 4, like list of numbers. I may have a list of odd numbers. I may have a list of even numbers. I may have a list of students. I may have a list of friends. Okay. I may have a list of my favorite things or any object. Okay. So in general, a list is similar to a set. And how do we implement, like for instance, a set of items in programming language? In one of the data structure that you know, you are familiar with array, right? An array is a kind of list, but it is a static list. So an array is a kind of static list. Okay, you are familiar with an array, right? An array is a static list. The reason we call array is a static list because once you fix the size of an array, once you put the size of an array, or you put the initial value, initial element of an array, so then its size becomes fixed. Then there is no way to extend its size. For instance, if you initially declare an array of size 10, but later if you see that, oh, you have more items to be put in the list, in the array, right? Like 12 items or 15 items or even 11 items. Then you cannot do it using array. You have to declare another array and you have to transfer your elements from your previous array to the new array. So that is time consuming. Okay, or otherwise, for instance, if you have declared an array with 1,000 elements, but finally you see that you have only 10 elements or fewer number of elements, then you can put all of your available elements to the array, but you will have misused some memory spaces, right? You cannot reuse, you cannot use that memory spaces that are allocated for the array for other purposes. So these are the two limitations for regular array, or we call static array. Okay. So in order to resolve those kind of issues with static array, okay, so it is required that we should have a dynamic array. So in such a dynamic array, we will be able to add any number of elements in our list, no matter if I have 5 elements, 1 element, or 10 elements, or 1,000 elements. That means if I am not sure, okay, if I am not, like, if I do not know ahead of time how many elements I have to keep in my list, then it is suitable to use linked list. Okay. So linked list, so the name itself refers, the linked list is a dynamic data structure. The name itself refers a linked list, right? What is meant by linked? Linked means joined. Joined with what? Yes, with other elements. Joined with other elements. So if I have a list, for instance, if I have a list, I'm trying if I can. No. So for instance, if I have one element and then I have another element, second element, I have third element. Okay. So the list means, for instance, every element, this element will be connected to the next element. Like 1 will be connected to that element, okay, sorry, to the next element 2. And 2 will be connected to the next element 3. Likewise, one element, all of the middle elements will be connected to its previous element as well as its next element. Like for instance, 3 will be connected to its previous element 1 and its next element 3. The first element will not be, the top element will not be connected with anything, 2 things. It will be connected with 1 thing. It will know its next node or next element. The second element will know its previous element as well as its next element, and the third element will know if it is the ending element then it will have a null pointer or something. So actually that means in this way, so how it is possible? So it is possible by if every element in our list contains two things. For instance, this element contains, every element in the list contains two parts, one for data and another for next address or link of the next element. This is called link. If I say link, this link will be the address of the next element. So by this way, it is possible that one element will contain data as well as address of the next element. Understand? Okay. So this is the concept of linked list. Linked list. Okay. That means a list. All of the elements in the list are linked together. Okay. Now, okay. So it is possible within a linked list I can put any new data, any new element in any position. If I want to put a new element, for instance, another 2 in between 2 and 3, then initial link will be broken. Okay, so this initial link will be broken. And then how it will work? So then it will work in a way that this 2 will connect with this 2, and this 2 will be connected with this 2 will be connected with this 3. So how it is possible that previous link will be broken or destroyed, okay, or replaced by a new link. So by doing so, it is possible that we can add any number of elements in our list. Then we will not have any, like what is called memory misuse issue, okay, or size restriction that we face in static array. Okay, so in this way, that means in a linked list, every element contains two things. One is data, and another is the address of the next element, next element. So we call an element as a node. Okay, so each node may have a data, any kind of data. This data can be a string type, it can be an integer type, it can be a float type or double type, no matter. And the important thing that this will contain another node. See that this node and this node, actually this is the same type, right? These are the same type, same variable, or same object. Okay. So kind of recursion, okay. So I can add this until I find the null node. Any node that is in value null, that will be the last or ending element. Okay. So you will learn more about linked list in your data structure class. So you will implement your full node, program, a complete program using it in your data structure class. But really, these implementations are not easy, really tough, and it needs clear concept. And now let us come to the our title, which says the title of the chapter is says linked list, plural, right? That means there are two different kinds of linked list. One is called single linked list, another is called doubly linked list. Singly linked list, or another is called doubly linked list. Singly linked list is that it can be grown in one way. Only you can add new element at the middle or at the end, at any middle position or end position, not in the top position, first position, okay? But there is a doubly link that is called, that has facility you can add at the beginning or as well as the middle as well as in the last position. This is why our chapter is title is linked list plural, okay? So linked list is an appropriate data type when we do not know our data size or list size or set size ahead of time. That is unpredictable size, if we have unpredictable data size. And since it does not misuse memory, so it is efficient, but still if you have a recursive program creating your linked list, and if you do not set an ending point, then still it will be looping, and then maybe at some point it will overflow. But this is a program error if you can find an overflow. So far understand what is a linked list? Everybody understand? Please give sound, okay? Okay, thank you. Okay, so then my question is that what next refers here? Next refers to a link. That link contains an address of the next element. Okay. The implementation is difficult really, but there is a good thing that most of the programming languages like Java and modern programming languages in Java and then in C#, they have built-in linked list, which they call Arraylist. Okay, if you know how to add elements, then you can use that simple add method that you have seen that in your GUI class. If you want to add web elements, you just use add method, right, on the panel, on the pen. That is actually element linked list. Okay, so most of the languages they have the built-in linked list. It's called linked list. Then it is easy to use linked list. Linked list has your add method, add all method, delete method, or find method to find whether an element exists or not. Okay, but although it is available in programming languages as built-in, but still we need to learn how to develop a linked list. Especially when you take your data structure class, then it will be horrible. Okay, so then you have to implement like linked list without using any existing method. Okay, all method you have to build in your own. You have to use your own method. Okay, so in this class, get some idea how to implement linked list and how to use it. Then later, when you have more experience and confidence in programming, then you can do that. Okay. Okay, so I already discussed this. So this is a linked list. Okay, this is structure. You see. So this is the initial node. Okay, this is the top one. Okay, the top one, it says it has only pointed this one. it will show that this node, this link will show the starting point of your list. Okay, for instance, when you declare a variable or an array, so we get a name of the variable or of an array. Actually, we get a we get some memory space, memory locations by the name, right? And we get the first location, first byte address of the name. For instance, if I say int x, then x we will get, x will contain, x will take the memory space, and the address of the 4-byte memory space is integer. For integer, it will take 4 bytes, and x will contain the first byte among the 4 bytes address. Similarly, this linked list, the initial pointer over here, it will contain the starting position, in which position in memory the linked list will start. Okay, then the second one is a complete node. The second one is a complete node. First part will contain a data, and the second part will contain, okay, the location or address of the next node. Okay, and at the last one, at the lastmost node, will contain a null value. So here they said, in this here it said that it's a bar cross. By cross they put actually they mean the null. Okay. So what is a node? A node is actually an object. Okay, that contains two things. One thing is a data, and the thing is a location of the next node. Okay, that means address. And the data can be any type. It can be an integer type, it can be a string type, it can be a float type or double type, or it can be any class type. It can be an object. So once we have a linked list, we can do regular, there are a bunch of, there are like maybe eight common operations for a linked list. Like insertion, there are two kinds of insertion. Inserting at the front, there are actually three kinds of insertion. Insertion in the front, insertion of the end, and insertion in the middle point. So the first one, it says insertion to the front, and inserting to the end, and inserting in between front and end. And similarly, we can delete a node, and we can search whether an element exists in the list or not, or we can do something, we can sort a linked list. If I have a linked list that is unsorted, I can sort it. If I have an ascending order sorted, I can make a descending order. So this operation takes different kind of time. It takes time. The time, how much time it will take, it depends on the operation. If I need to insert an element at the end, it's easy. If I want to delete an element from the end, it's easy. But if I want to insert an element in middle, for instance here, if I want to put, that means what I have to do, every node will contain two things. In your book, you will see that this symbol. Okay, so this will contain this will contain this will mark this. And now, if we need to delete, for instance, delete one of them elements from the middle, then what you have to do? You have to delete this node. Actually, then you have to delete this node, this link, and then you have to move this link to here. Nothing can be unlinked. If you delete one item, the other two items need to be connected, right? And if you add another item, for instance, here if you add another item, another 4 items, then what you need to do? You need to replace this location from here to there, and you need to assign this to here. It will create a chain. Actually, it is a kind of chain. Anybody has any question? Yeah.
So, if you're at 2, can you look for 1, or is it only a one-way thing? Does that make sense?
So your question is, if I want to add another number 2.
Well, because right now 1 has like points at 2, right? 1 has the reference for where 2 is.
Yes.
So the 2 have the reference for where 1 is. Does that make sense?
Like everything behind the yeah.
So you have necklace, right? Sometimes you wear necklace, right? Necklace? You wear necklace? How necklace is built? It's a chain, right?
Yeah.
One circle is connected with another circle, right? Or 2 circles. That's same thing. Yes.
So if you do a sort that moves the things in the list out of order, does that change where each link leads to?
We will come to sorting is difficult.
Okay.
We will come to the sort later. That's easy that you can create another. There are 2 kinds of sorting. It's called an in-place sorting, and then you can create another link, another new list, and you put you search the elements from here, and then create another sorted list, and putting the appropriate element. That is another way. You can create. Yeah, you can create another list.
Okay.
There are 2 ways they are used. But in place, another call is in place. That means you, for instance, I have this one is ascending order, right? From small to high. Then if you want to make it descending order, the in place, that is, 5 will be replaced with 1, 2 will be replaced with 4. Okay, that is a way. Yes.
Were you asking because the arrows are just pointing one direction if it's only a one direction link, right? Yes. Yeah. Because the way the arrow is set up, the link is only going from 1 to 2 for just linking them together. But from the point 2, can you reference back to 1 like a chain, like how they're linked together, or is it just
like W linked list? There is another kind of linked list that has. You are asking me this way, 2 nodes. Are you asking me this way? So like you have data and then here and then how we should do it? Yeah? Are you asking this?
yeah?
Let us see. Let us start from the simple thing, okay? Let us start from the simple thing. I don't like to make it complicated at this point. Yeah. Yeah. Let us keep your brain cool until you get your second test.
Okay.
Okay. After your test, we will jump into the fire. Okay. What time is it? Patrick, how many minutes do you have?
A lot.
A lot?
Yeah.
Okay.
Like 40 minutes.
Okay, so there are some pseudo codes or algorithm for insertion operator and then deletion operator. Let me see how far that points. Actually, I discussed some of these already. Deleting head nodes. Let me see how many insertion, deletion. Let me see how many actually it has. Okay, I will be able to cover this in next class. Okay, so far I will be happy. So far, whatever I told about linked list, if you please remember this. Okay, if you do not forget this, and then you will get interest when we do like in insertion method. Okay, insertion method needs at least 3 steps. Okay. There is a mistake over here. I will fix this. There is a mistake over here in this slide. So if you do not have any question until this, I like you to, after your test, okay, after your test day, please read this up until this your chapter, until read the book and get some preliminary idea. Okay, then we will go through from here. Okay. Anyone has any question? So how is this class going on? Now? Good? So that means you are getting interest, right? Yes. Initially I told you that initially this class will be like coconut. Right? You have to break down the coconut. Once you can break down the coconut, then you will get interest. Okay? Some people left. I see that about 12 people they dropped from this class. Okay? Okay, so if you don't have any question right now, then I have some questions about your upcoming test. Okay, I want to ask you some questions and then let us see how do you respond. So most of the time I use Java. That means the people who are taking C# class don't mind. Okay, so I can do C# as well as. Okay, but my intention is to teach you the logic. Once you understand logic, the difference there are some points in difference. Okay, what is an abstract class? Yes. Okay, what is an abstract method? Yes. Yes. So why do we use abstract class? Yeah, actually we use abstract class in order to resolve some limitations that inheritance has, right? If we figure out there are at least 3 or 4 limitations in inheritance, right? So through let me start. Did I delete it? Man, I deleted. Okay, I deleted, but I can quickly retry. Let me go to my GitHub and then quickly retry. How many of you have started using GitHub? How many of you have started using GitHub? You have? Okay. Then if you start using GitHub, then your life will be easier. You know that my programs all are deleted, so then I can quickly get my project. Like git. What is the git clone command? Can anyone help me? Git clone. Yes. Okay, so see I'm online. Git clone as the address of the repository. So git repository address ends with .git. Sorry, I have to git, not got. That is a mistake. You see how many seconds it took? 5 seconds, or less than 5 seconds, right? So then once I have my project up here, then I can do import, file import, and then general existing project to workspace. Next, I will select this one, and select projects. Done. Okay, so I will write one program and I will discuss two things: inheritance and polymorphism. Okay. So abstraction and polymorphism. So abstraction is implemented using two ways. One is abstract class and another is, what is that? Interface. Okay, you understand that what is an interface? What is the difference between an abstract class and an interface?
An interface is 100% abstract.
Yes. And? Okay, then I need at least 3 or 4 differences. We know at least 3 or 4 differences, right? So inherit an abstract class is extended, right? But an interface is implemented, right? Okay, what is another difference? Yes. Yes. Okay. And can an interface extend another interface? Yes, an interface can extend another interface. But when we implement an interface, we use implement keyword. Okay. What is mean by implementation? Implement. What do we mean by we implement an abstract class or an interface? What do we understand by that?
Provide code for the abstract method.
Yes, we put the implementation or body of the abstract method, right? Like for instance, let us start from here. This is my, everybody can see from the back. This is my class is mammal. Okay, okay. So instead of mammal, I want to make it maybe animal. So how can I do that? You know, refactoring. Okay. Okay. So I just select this one and maybe Shift Control R. Okay, no, Alt or Shift R maybe, no? Okay, Alt or Shift R. Then I want to make it animal. And press enter, it's done. All places will be replaced. Alt or Shift R. Alt Shift R. Alt plus Shift plus R. Okay, so in the line number 5, let us discuss line number 5. So this is an abstract class. An abstract class start with an abstract keyword, right? Okay, and then is abstract class animal, right? We have extended object. It is optional. Every class by default extends object class, right? So for here I said extends object, it is optional. Even if I say it or I delete it, but it does not have any effect. Okay, and let us see that my class, I have one method here, that is public void abstract void, abstract public void move. Okay, that means my animal, any of my animal instance will be able to move, right? Okay, so this method we are putting abstract because we do not want this move method implement here. Okay, so as we know that different animal move different way. Different animals move different way, right? Human moves one way, birds move another way, right? Snakes moves another way. So that we don't know yet ahead of time, but because we do not have a fixed way for our movement, fixed implementation, this is why we need to make it abstract. This abstraction means that any other class, okay, two things it means that this abstraction class, we cannot create an object for this abstract class. Can we create an object? We cannot declare an object for this abstract class. Okay, or an interface we cannot create, and we will see that. Okay, so for instance, then since we do not know what we will have in our move method, so this is why we are not giving its body, we are giving its signature, just its signature of this method. Okay, and then if I want to make a body, for instance, within parentheses opening and closing, then it will, I want to do this, it will give me an error message. What is that error for? Yes, let us move my cursor over here, and it will say abstract method do not specify a body, right? I have two ways to resolve this issue. One way is I can remove abstract modifier, right? I can delete abstract modifier, or another way I can remove the body. What do you want here? Okay, so we are doing a demo for abstract class or abstract method, so I don't need a body, right? So then body is not needed. Okay, so then I have a non-abstract method. How do I know it is a non-abstract method? Yeah, there is no abstract modifier, right? Okay. Okay, now I have, for this non-abstract method, I have its own body. Okay, now I have a new class, that is human, that is extending animal. Okay, so if I want this way, if I want extend, so for instance, if I do class human extends animal, okay, then it is showing me an error initially. What is an error for? Yeah, if I hover my mouse over here, this says add unimplemented method. Okay, I have two options again here. Either I have to make add the unimplemented methods, okay, or I can make again human and abstract class. Okay, the second option that I made, if I make human abstract, then this issue will be resolved. But I cannot create a human. Okay, then I will not be able to create a human object. Okay, so then actually I need the second option, first option, add unimplemented method. How many unimplemented methods over here I have? How many unimplemented methods here? Yes, one. What is that one? Yes, that is move. So if I add unimplemented method, click over here. So it is giving me a skeleton, just an empty move method. Okay, with override annotation, and it says public void move. Okay, and you see, look at here. This method has the same signature like this, except it does not have abstract. Right? The same signature. Okay. So abstraction happens between two classes. Right? So this is the parent class, and then we are implementing here. So okay. So one, we implement the unimplemented abstract method, it is happy. Even I have an empty method, no matter. Right? This method I have nothing in body. I have empty. Okay. Okay. Now my question is that, okay, can I add any more method in my human class? Any more method? Yes. I can add any more method, right? I can add void talk, because human can talk, right? Then I put this out. That I can say human can walk, or human can talk. Okay. Now my question is that now it is happy so far, right? Okay. Now can I override? Okay. So let me do. So this method is empty. Move method is empty now, right? So let me add something here. So sys out, and then control plus space bar is the shortcut to bring system.out.print line. So okay, so I want to put here mammal. I want to put here some text like move method within human class, so that if I see this output, then I will know that this method is called. Invoked, right? Okay, so now I have overridden which method? The unimplemented abstract method, right? Okay, so this is actually this part is an example of an abstract class and its implementation. Okay, so polymorphism is another thing.
No, I'm saying that's polymorphism right there, right?
I'm discussing about abstract class.
I know, but you overrode the method. So.
It's polymorphism. Yeah, polymorphism actually is not. I will discuss polymorphism later. Until this, you understand this one? Okay. So now, what else? If I want to make this abstract, okay. So later I will do that. Okay. So now, can I can I override this non-abstract method? That means can I have a different implementation of this non-abstract method? Okay, let us see. Copy this one and put it over here. Okay, I'm just saving my time. Okay. So yes, it does not make any error, right? But it does not make any error, but the convention is that since this method already exists in its parent class, okay, so then I should, as a courtesy, I should put an override annotation here. Okay, so let me say it's human. Within human, I have non-abstract method implemented here, right? Okay, so let me do. So select all, then Control plus I, it will make alignment. And Control plus D will delete unnecessary lines. Okay, so I don't need this line, so Control plus D, then it will delete this line. Okay, so let me set some space. Okay. So similarly, I can create another method, class bird, that extends animals. Right? So inheritance allows that a parent can have multiple children. Okay, so this animal has a children called human, and another children is called bird as a child. Okay, this way I can have any numbers. Okay. So in order to, okay, so I don't need this for now. I'm sorry. Maybe I don't need for this bird class. Okay, so let us make it simple. So I don't need bird class. Same thing. I have overridden this one. So if we understand one thing, then we understand. I don't need this one. Okay. Now we will discuss about polymorphism. Polymorphism is actually a polymorphism has some characteristics. In the slide there are some characteristics. Okay, the potential question. There are 4 characteristics in the polymorphism slide. You will see the polymorphism needs a class hierarchy. That means what do we have? So polymorphism requirements. What are the requirements of polymorphism? First one is that classes are in the same hierarchy, right? So are my classes in the same hierarchy? Yes. So the animal and human are same hierarchy, right? These are not distinct, right? So my classes are hierarchical. Okay, all subclasses override the targeted method, right? So I have only one subclass. Okay, this subclass is human. It is implementing the target or parent class. It is extending the parent class, and this is overriding its method, right? The second requirement is fulfilled. Okay, and then these 2 are critical things. Okay, let us try to understand this. A subclass object reference is assigned to a superclass or base class object reference. and then the superclass or base class object reference is used to call the target method. Remember, the difference between these two characters are very critical. Okay, and try to understand for this one. Okay, potential question for the exam. Polymorphism requirements. Okay, read the slide later, but let me explain what does this mean and what does this mean. Okay, so now I have a non-abstract method here in this class, and I have same non-abstract method I have overridden here in my child class, right? So now in my main method, okay, so let us create an object animal. If I say animal A, there is no error, right? What is A here? Is an object reference, right? Okay, so A here. Okay, so can I say animal A equal to, I have already animal already A. Can I say A equal to new animal?
Yes.
Can I say this?
Yes.
How many say yes? How many are the people who are not listening me? Like they said no, right? They did not raise their hand. Okay, so it will not allow me because, can you remember the reason? Animal is an abstract class. We cannot create an object for an abstract class, right? Okay, so then since we cannot do it because it will say cannot instantiate the type animal, because animal is here and is an abstract type, right? Okay, so then what are alternatives here? How can I create an instance of animal? Yes, use a non-abstract instance. What is my non-abstract class here? Human, right? Okay, then if I now is happy, right? Now if I say A dot, I have move here, right? A dot move, right? Okay, so the move method is only implemented one time or two times. My move method is implemented only one time in the concrete class, right? So it is clear that this move will be called. The human move will be called. I have move only one place, right? Okay, so let me go back to my previous, actually the bird one that I deleted. I need that one. Okay, so actually I want to do that. Let me go back here quickly. My bird class. I have my bird class. Okay, so that I want to explain here. So let me come back here. So I said animal A, then it's happy. If I say A equal to new animal, it is not happy, right? Okay, that what I need to do, A equal to new human, for instance. Then it is happy, right? Okay, now if I call A dot move, then which method I will get? Let me comment it out everything except here to or let me do this way in order to explain. Sit out dot, let me give a boundary. So we will see the output until this, up to the boundary. Okay, so later we will not see this. Okay, so let me run this. So if I run my program, I will see the output only this part. You see, move in the human class, right? Is it showing that again? So I will see the output only above of my boundary. Okay, so do not follow this later on. Okay, so it is showing some move, human move, right? Because I have, okay, so now if I say a equal to, instead of human, if I say bird, can I do that? Yeah. If I say a dot move, what output I will get? So bird, right? This I have here in this move. Bird cannot walk, can't walk, but fly. Okay, then not run. Okay. So but can fly. Okay. So then my output will be this one, right? Okay. Now let us see. Okay. So then if I call this fly method, okay, fly method is only in bird, right? So I have no doubt that if I say a dot fly, if I say a dot fly, okay, this is the fly. Okay, instead of, let me see how this fly. Okay, I know that the reason, because it is type animal. Okay, you cannot call it. Okay, so this is this is one of the 2 points that we want to focus. Okay, now let us call the non-abstract method. Okay, so if I say a dot non-abstract method, okay, the same method, right? What it will call? Within bird, it is calling the within bird class, right? Okay, so now if I change it here, instead of bird, then if I say human, so then you see I have only one change. This is the polymorphism. Okay, polymorphism is happening here. If I have done only one change, okay, then what will happen? You see, compared to my previous output, I will see that this move is calling from my human class, as well as this non-abstract method is calling from human class. Okay. Now in my human class, go back, I have a method that's called talk, right? Okay. So now let us see that the restriction I got. Can I call a dot talk? What is the reason? Okay. So let us, the reason is that, here we have animal that is broad class, super class, parent class, okay? And it has 2 subclasses. One is called bird class, another is called human class, right? But so here, the 2 things over here. So for instance, these two lines can be written in one line, like this way. Animal A equal to new animal. It can be written this way, right? In one sentence, right? These two sentences can be written as, you see that this can be written as this way. Oh, sorry. Yeah, sorry, abstract, not animal, human. Yes, human. We can write this way, right? Okay, so but in order to understand polymorphism, I like to write this way. Instead of writing in one sentence, I want to write using two sentences, two instructions, okay? Then it will be, because it's getting an error. Now the polymorphism will Paris, give me attention please. Okay, so now I see, if I say, okay, the reason is that I cannot call talk. I know that talk is a method of human, right? But I cannot call here. The reason is that this is type. My type is here abstract type, right? If I say human over here, then something, no error, right? Then I can here call here a dot. I have my talk method over here. You see? Then I can call talk, right? And then, for instance, then this line will be then human A equal to new human. So this human at the top is a type, and this is as the instant. You need to understand between type and instant. Okay, so that means human, we will check how it is possible. Okay, so like, okay, but we can now in the question, can we do like this way? Can we say human A equal to new animal? Why? There are two question answers. One is that animal is an abstract class, so I cannot instantiate an abstract class, right? Another thing is that, actually, like this way, are all animals human? No, right? Not all elements are animals are human, right? Some animals we know that they are birds. Okay, but in opposite order, we can do in opposite order. We can do here animal A equal to new. We cannot do animal, but we can do human. We can do it because all humans are animals. So go assignment operator works from right to left, right? So say all animals are human. Okay. So I'm almost done. So but now the restriction is that when you are using this way, you cannot talk equal this method. So these are the things it is said in the slide. Where we left the slide, the requirements here, you see, the two requirements. Try to understand this, the two requirements, okay? Give me 2 more minutes, let me see one thing. Okay, so another thing is that, for instance, okay, so now if I have my animal class non-abstracted, regular class, okay, I have my animal class non-abstracted, okay, not regular. Okay, so then I have a body over here. Let me do quickly a body, add a body. Okay, so then I see move within the Give me 5 minutes, please. Okay. So this animal is okay. So this animal is non-abstract, right? So there is no problem. I have moved over here and I have moved overridden in my human class, right? So now let us see. Am I able to do that? Animal A equal to new animal. Okay, I can do that, right? Okay. Now if I say A dot animal. If I say A dot animal, which animal will be called? Okay. My animal is coming A dot move. Okay, move is coming from mammal. Mammal is calling from my what is that called? Child class. How can I call move from my parent class? Super dot will it work? No. I want to call this move from my animal. Move from my animal. A dot move, it is showing animal move. Let me see A dot. What is my A dot animal move? It should show me here. How is coming A dot animal? But okay, it's coming A dot animal. Okay, but did I? Okay, so now if I say animal A equal to new bird, then you see the bird's move method is calling. Okay, so then another thing is that what is a string and string reference, you know that, right? Okay, and then in the string there are some methods like string concatenate, substring methods, and then position at, character at method. Okay, and then what is the last slide has? The string has last slide has some methods. Index of, right? Why index of is used? To find, so if you want to ask to find whether find the position of a character in a string. Like if you have Java programming, for instance, if you have a string, for instance, hello world, how can we find the position of W, the index of W? By using index of W. Like for instance, E, by finding using my string dot index of E. Index of method returns the position of index, right? And character at method returns the character at an index. Okay, and there is a study guide in the announcement. Okay, anyone has any question? Okay, thank you so much.